Hello everyone, my name is Li. I'm the PhD student in Space Lab in NGIT. I would like to introduce my supervisor, Dr. Shaohua Wang, and our collaborator, Dr. Tim Yan. Today, my topic is context-based automated approach for method name consistency checking and suggestion. During the software development process, the developers often need to use the existing methods or predefined APIs to solve the new problems. But the inconsistency between the method name and the method body for the existing method may confusing and misleading the developers. For example, in this piece of code, the method name is getRowHeaderHeight, but in the method body, they mention the row header width for several times. In this case, the developer will have a hard time to understand if this method is really to get the height or get width for the row header. To deal with this kind of problem, in software engineering areas, we have two scenarios need to face. The first scenario is that we need to suggest the alternative for an inconsistent method name, just we mentioned as previous slides. The second scenario is that we already have the method body, but we want to predict and suggest a method name for the developers. With these two kind of scenario, in the software engineering area, there are many state-of-the-art approaches dealing them, but they are mainly in two different groups. The first group is that the information retrieval-based approaches, while the second is the machine learning-based approach. As for the information retrieval-based approach, their strategy is very straightforward. They think that the similar method body should have similar method name. Then in this case, they often doing the searching for the similar bodies to suggest the similar method names for a given piece of code. But they have the limitation that if there is a method name never appear, they cannot recommend the correct method name for the given piece of code. Well, the second kind of approach is the machine learning-based approach. They directly generating the method name based on the method body, but they also have the key limitation that they cannot deal with the very short methods that have little content, or the content inside of this method is general purpose. To overcome the limitation of the existing two groups of approaches, we come up our approach, which named the DEEPNAME. And we have several key ideas here. The first key idea is that show me your friend, I will tell you who you are. This sentence means that we not only want to learn what the method contains, but we also want to learn what the method caller or callee contains. Based on the caller callee information, they can suggest the correct method name for the current method. The second key idea is that we want to learn the information from multiple ways, multiple contexts. This context including the internal context, interaction context, sibling context, and the enclosing context. The details of each context we will introduce later. With the key ideas shown in this slide, we come up with the overview of our approach. Here is the whole process of our DEEPNAME approach. By having the methods from the given project, we firstly build the context, and then we use the embedding techniques to learn the representation vectors for this context. By combining these two steps together, we call it a context representation. In context representation, the most important thing is that what are the four types of context that we predefine. We use an example to explain that. First of all, our main method is the process family statement. So the method body of this method, including the return type and the input parameter types, all of them combining together at internal context. And inside this method, they call the other method, which is the liveness. So the liveness is the callee of the process family statement. All the caller and the callee of our main method, we call it the incorrecting context. Next, the third type of context is that in the same class variable liveness, they have some other methods such as process break statements. This method, we call them the sibling context. The last type of context is about class. We collect the class name and the variable defining the class. We collect them all this information together as the enclosing context. By having all of these four contexts together, we can do the context building and the context representation learning. Then the next step is that we put the learned context vectors into the context-based method representation learning model. By passing through this model, we have the method representation vector. In method representation step, we use the sequence-to-sequence framework to learn the method representation vector. First of all, we use the four types of context as input and put several GRUs as the encoders for the sequence-to-sequence framework. And then we have the other decoders to generate the method representation vector. In this step, we also apply the copy and the non-copy mode. The copy mode means that we directly copy the subtokens from the input instead of generating that. The non-copy mode means that we learn the word distribution and saying that the stub token should not be directly copied from input because this stub token never appear together with previous few tokens. By having the sequence-to-sequence framework with copy and non-copy mode, we can learn method representation vector. After having the method representation vector, based on the two scenarios, we have two different downstream tasks. The first one is the consistency checking for the method name, while the second one is the method name recommendation. So for the first one, we build a classifier to classify if the method is consistent or not, while the second one, we directly generated a method for a given method body. These two downstream tasks together, we call it the detection and the generation step. After having the whole approach of our DEEPNAME, we do the evaluation for our DEEPNAME. The first thing we want to evaluate is that how our approach perform on the method consistency checking. We compare with the baseline from Liu is from the XE19 and Amir is from XE20. And then we evaluate our performance on the name suggestion. We compare with the baseline code-to-vec, code-to-sequence, Amir, and path-based representation. Also, in our paper, we also have the RQ3, 4, 5, and 6. Based on the time limit, we will not talk them in detail, but you can refer back to our paper for the detailed information if you're interested in them. In our approach, when doing the evaluation, we use the dataset, the corpus for consistency checking from the Liu's paper that contains 430 projects with about 440K unique method names. And for the method name suggestion task, we directly use the dataset from the code-to-vec. This dataset collected from over 10K Java projects with over 1.8 million unique files. We use the precision we call F-score, accuracy, and exact match to evaluate the performance of our approach and baselines. Here, the exact match means that we generate the method name exactly match the actual name of the method. As for the evaluation results, for the first research question, method consistency checking, we evaluate our approach and baselines in both consistent and inconsistent scenario, and we calculate overall accuracy for all of these baselines and our approach. From the results in this table, we can see that our approach can always get higher F-score on both consistent and inconsistent setting. As a summary, our DEEPNAME improves the F-score by 11.9% to 33.9% comparing with baselines on both the consistency and inconsistency checking. As for the second research question, which is the method name prediction, we evaluate our approach with all four baselines by using the evaluation metrics exact match, precision, recall, and F-score. From the results in this table, we can see that our approach can always get higher exact match than all the baselines. As a summary, our DEEPNAME can predict the method name better than all baselines by 13.9% to 104.1%. As we have the results in the previous two slides, we found that our approach can always perform better than all the baselines. Here, we want to use an example to show how actually each feature contributes to our model final performance. We use the same example we previously used here. So in this example, the main method is the process finally statement, and we have its callee, which is the method levelness, and we have the sibling context, which is the other method in the same class, and we also have the enclosing context about the class information. For this example, when our approach only has internal context, our approach cannot predict the correct method name in the top 10 results, but some key stub tokens like finally and a statement already in the top 10 results. When we adding the enclosing context, the method name still not here, but the key stub tokens like finally already ranking higher. And when we adding the sibling context, the correct method name appear in the top 10 results, it's at the top 7. And after this, when adding each feature one by one, the correct answer has ranking higher. In the end, when we're adding all the features, including the 4 key contexts, copy and non-copy mechanism, the correct method name has been ranked in the top 1. So this results prove that by adding each feature, our approach can have a better result, means that each of them contribute to the final performance of our approach. After talking about an example, I want to make a summary for today's presentation. So in our today's presentation, we firstly talk about our task in 2 different scenarios, including the method name consistency checking and method name suggestion. Then we talk about the key ideas in our approach DEEPNAME, and we carefully introduce the copy mechanism and the non-copy mechanism in method representation learning step. And after having our approach, we compare our approach with all the baselines on both the method name consistency checking scenario and the method name recommendation scenario. The results prove that our approach can always perform better than the baselines. So it means that our research is success and useful. So this is all about my presentation today. If you have any question, please ask. Thank you.
Hi, everyone. Welcome back to the Q&A session for the paper titled A Context-Based Automated Approach for Method Name Consistency Checking and Suggestion. We have the pleasure to have here Ting Nguyen and Yi Li, and they will be very happy to answer your questions. So please, if you have any, just pop them on the chat and I'll be happy to read them for you. While the questions start appearing, perhaps I can ask one that comes to my mind. That has to do with the practicality of using this approach in a software engineering context. How much data do I need for the approach to be, let's say, worthwhile in a software organization? How many projects, how much training data would be needed?
Because our model using the deep learning approaches, so when training the model, it may need a little bit big data. In our project, in our paper, we use about 9,000 projects to do the training, and we evaluate our approach on about 1,000 projects.
Mm-hmm. So how would that translate to a project, for example, written with certain coding guidelines or naming conventions? Is it something that you take from open source projects, something that could be applicable when, for example, the Google naming style is applied?
Actually, we want to keep our project running in the real data to make sure it can also work for the real project. So when we're collecting data, we also collect from the real projects, including some Google data. And actually, we tested on the Google naming framework. They're very special, but our work can also works as our expected in their dataset with their naming styles and rules.
So currently, the approach I would add is independent of the code convention or naming convention. So integrating the naming convention into the model is something that we would think in the future. But currently, the model can learn the naming convention automatically. But of course, if we have the rule and naming convention, we can combine the rule base with the machine learning to actually give a better accuracy, higher performance.
That sounds great, actually. Yes, we have 3 questions from the audience now. The first one is from Fatima Fard. Again, thank you very much, Fatima, for participating. Great work, she says. Is the data set you used for your model open source, the one you used for capturing different contexts?
Yes, it's open source. We have 2 RQs. One is doing the name consistency checking. We use the data set from the existing work, the Liu's paper. And this dataset is published by their paper. And the other dataset we use is for the second research question to the method name suggestion. This dataset is from the famous paper Code to Act. So we all use the public dataset. You can directly collect them online from their existing works.
Thank you very much. If you want Yi to paste the link to your data set or something like this, you can do that on the chat as well.
Yeah.
We have a question from Dor. You show that your methods generate names that are similar to the original ones. Do you have any notion of the actual quality of the names and what affects the quality of the names?
So in our paper, we use some example to show the quality of the name and the influence of that. So we pick some existing methods with the inconsistent name. Then if you are or am a new developer coming to this project, we go through the example, we read the body, then we think the method doing this function, but we found that, oh, the method name or the title is totally different from what I thought. Then I was confused. So it's a very common problem reported in the GitHub or some other development forums. A lot of developers will report this problem, saying that, oh, this name is very confusing and people don't understand what this actually works. So we just want to solve the problems like this in the real situation, real world. Yeah.
So may I ask something? So actually, to answer more in depth is actually currently the actual quality we worry about more on the naming correctly with what the original authors gave. We do not consider quality yet. So that's a very good suggestion.
Drawer.
Yeah, drawer. Yeah, because right now we consider correctly if we recommend the same with the original name, but we haven't looked at if that name is high quality or not. I think that maybe requires something that manual or human inspection of the name and to see if it's understandable. So that's something that beyond a little bit that could be our next step. Yeah.
Maybe you guys can collaborate, because Dror was talking earlier on this same session about how to choose names. Oh. So perhaps there is some synergies between the two works that you could explore.
Is that the work you do, ID bench, Dror? Or?
The one before. The one before.
Before the ID bench? Oh,
yes.
Okay.
Yes.
Yeah, that's good to know.
We have a question from Alex Hoppen. Have you considered how your framework can suggest names for functions without bodies? And this is a very nice use case, right? For example, when you are developing code and you are writing your next function, perhaps your approach could tell the developer, this is the more appropriate name for the next function that you're going to write.
It's a good future work for our research. Currently, our model don't have the functionality for this one, but this is interesting directions for the next step. And also, this one is also a little bit different from our work. So currently, what we are doing is checking from the existing body to check the name. Then this kind of suggestion, the target is that we, based on the user description, maybe some words, then we make a summary that what the user functionality they really need. So it's a little bit different, but it's also a good and interesting idea that we may do in the next step. Yeah.
So may I follow up with the question that I think the comment that Draw put it there. So we are not trying to replicate the original name. In the data set, the original name is the one that have been renamed by the authors and considered to be a good name. So that's the data set that we use. The data set we use it from Leo and others. They mine the history and see the commit log that people change the name from a confusing one to the correct one, and we use that correct one as our ground truth. What I meant for you in earlier comment is that consider high quality is something that the model did not look at yet. Okay, so we consider the data set that people give for training is high quality. So it's not meaning that it's bad name or ill-advised name. So
George is happy. There was a smiley flying around, so I think he's happy.
Yeah. So the other one is the body, empty body.
Huh?
Oops. We lost him.
Yeah, I don't know.
We lost him. He has 1 minute to join and respond to Alex. I think he was going to say something interesting. Yeah. So let's give him the opportunity. Let's give him the opportunity to join. But yeah, I do agree with Alex that sounds like a very, very interesting and intriguing way forward to explore.
Yeah.
Because if you already have your model construct, and then perhaps you could even venture into test-driven development, and you could use a similar model, for example, to generate names for test cases that need to be written. There are many ramifications, I think, to this work.
Yes, actually, yes. I'm agree with that. So I think it's a good future work direction. Yeah.
Mm-hmm.
So maybe he cannot back.
So no, that's fine. Alex, I think there he is. Tien, I'm afraid we don't have any more time for you to follow up on Alex's question. So I would suggest, as soon as the button pops up for you to join the discussion room, just click on that button so that you can elaborate a bit more and perhaps have a discussion with Alex and Dror. Apart from that, thank you both very much for the nice presentation and for the very nice paper.
Thank you.
And for the rest of the audience, there is one more paper in the session, and I look forward to talking to you next in 10 minutes. Thank you all very much.
Thank you.